Because we're solving a radical equation that has two radicals, our first step is to isolate one of these radicals. So the first thing I'm going to do is subtract the square root of x plus 2 from both sides. This will leave us with the square root of x minus 1 is equal to 3 minus the square root of x plus 2. Now I'll raise both sides to the power of the index, which is 2. On the left side of my equal sign, I'm going to be left with x minus 1 equals, and on the right side, remember I'm multiplying two binomials basically here together, 3 minus the square root of x plus 2. And when I do that, I'm going to have 9 minus 6 square roots of x plus 2 plus x plus 2. Notice that I eliminated one of my radicals, but I still have one more left. So now I need to isolate this radical and do the same process. So I'm going to combine my like terms on the right side here, and I'll also subtract x from both sides. When I subtract x from both sides, on the left here I have those x's canceling each other out. So I have negative 1 is equal to 11 minus 6 square roots of x plus 2. I don't have my radical isolated yet, so I'll subtract 11 from both sides and get negative 12 is equal to negative 6 times the square root of x plus 2. Still, I can isolate my radical further by dividing both sides by a negative 6. These two will cancel out, and I have 2 is equal to the square root of x plus 2. Now I have my radical isolated, and I'll again raise both sides to the power of my index, which is a 2. So I'm going to be left with 4 is equal to x plus 2. Solving this equation, I'll subtract 2 from both sides and get 2 is equal to x, or x is equal to 2. Now I need to check this solution in my original equation, and it turns out that this answer does check out, so x equals 2 is my solution.